In this chapter 11, you will learn how to display quantitative variables. You can use two kinds of graphs to display quantitative variables, histograms and stem plots. On the right here, you see a histogram. And last week, we have learned bar graphs. They're different. On the left, you see a bar graph that illustrates a categorical variable, the kind of pet people own. So on the horizontal axis, you have categories, the kind of animals. This is a category. And the height of each bar represents how many individuals own these kind of animals. So this is the display of a categorical variable. It's a bar graph. On the right, this is a histogram. This is what you're going to learn this week. The horizontal axis does not show categories. It shows numbers because histograms display quantitative variables. So this histogram displays the distribution of age in a population or a sample of 20 individuals. So the horizontal axis shows the age from 20 years old to 100 years old, and the height of each bar represents how many individuals are in each class. For example, between 20 and 30 years old, you have 2 subjects. You see another difference between a histogram on the right and a bar graph on the left. There's no space between the bars of a histogram unless a class is empty. In this case here, there's no one between 80 and 90 years old. So this class here is empty. There's no bar. So histograms show how a quantitative variable is distributed. I have an example here that I will see with you. Suppose I have a sample of 30 students, my anthropology class. And in my class of 30 students, I give a test on 100. And here you can see the 30 marks that correspond to my 30 students. It is a distribution of marks. If I want to do a histogram with this distribution, my first step will be to decide how I separate my horizontal axis. How big will be my classes or my subgroups? So I will first look at my lowest number. Here, if I look at my distribution, I see that my lowest number is 41%. This is the lowest mark. And my highest mark is 99%. So my histogram will have to show marks between 41 and 99. So I decide here I will have classes of 10. So each of my bars will represent an interval of 10 numbers, 10 marks. I will define my classes after, my classes of 10. So my first class will be students that have between 40 and 49, then those who have between 50 and 59, 60 and 69, and so forth. So you see on the left that I have 6 classes. I will have 6 bars in my histogram. The first one that will be on the left will represent students having between 40 and 49, and so on. Classes must be exclusive. This is important. I could not tell my first class on the left will represent students having between 40 and 50, and then those between 50 and 60, because my classes would not be exclusive. If a student has precisely 50%, in which class do I put him or her? It's impossible. So my classes must be exclusive. One individual will fall into one class only. So this was my first step in doing a histogram. Divide my data into different classes that are exclusive and decide the content of these classes. Then my second step will be to count how many students fall into each of the classes. For example, here I have 2 students who got between 40 and 49%. 2 students having between 50 and 59%. I have 5 students between 60 and 69%. I have 10 students. This is the most numerous class here. 10 students have between 70 and 79%. 7 students have between 80 and 89, and only 4 students have between 90 and 99. So I counted here how many students I have in each of the classes. And my final step will be to draw my histogram. I start by doing my 2 axes. My vertical axis will represent how many students I have in each class. So I see that my class in which I have the most students is between 70 and 79. I have 10 students. So my vertical axis will have to be divided between 1 and at least 10 here. And my horizontal axis will have to be divided between 40 and 99, because this is the minimum and the maximum of my distribution. When I put my numbers below my x-axis, I can go simple and only use round numbers. It's okay here. I could also do for my class on the left 40 to 49 and then 50 to 59, but I can also write, as I did here, 40, 50, 60, 70, and so on. It's okay. I have to give titles to each of my axes. So here the vertical axis will be for the number of students in each class, and the horizontal axis will represent the mark they have. And then it's easy. I just have to draw my bars at the right height. Between 40 and 49, I have 2 students, so my bar will go until number 2, and so on. And I have my histogram done. You will probably never have to draw a histogram in your life, because you will use a software for that. We live in the 21st century. No one really draws histograms anymore. But by drawing one and by knowing how to draw them and how to make them step by step, it makes you better at reading and understanding them when you see them after. So how do we read a histogram? You have many things to look at when you read a histogram. First, you can look at the spread. It's the distance between the minimum and the maximum of a distribution. So for example, here, this histogram shows a distribution of numbers from 0 to 1000. And this is the spread. The spread is 1000 here. If you know the spread, you know the center. The center is the exact midpoint of a distribution. For example, here, if my spread is 1000, from 0 to 1000, my center will be exactly at 500. It's also important to look at outliers in histograms, because outliers affect the distribution. For example, here in this figure, you have the distribution of marks. And you see that most individuals have between 50, probably percent, and 75%. And one individual has 10%. This individual is totally separated from the overall pattern of the distribution. This individual is considered an outlier, totally apart from the group. It is also important to look at the shape of the distribution. As a histogram or a distribution is symmetric when it looks like a bell curve, as you have here in the figure. When a distribution is symmetric, the midpoint or center is close to the peak of the curve. The peak of the curve, we call it the mode. We'll see that later. So for example, here, your distribution starts at 40 and ends at 160. So the midpoint, the center of the distribution is at 100. So the highest point here is 100, the highest point of the curve. So this is what we call a symmetric distribution. But in real life, distributions are not always symmetric. Very often, they're skewed left or they're skewed right. For example, here you see in this histogram on the figure that most individuals are in the classes on the left of the histogram. The histogram tails to the right here, so we say it is skewed right. This kind of histogram here shows a distribution that we call uniform distribution. It means that all classes have more or less the same amount of subjects. You don't see a trend here. So this is called a uniform distribution. A distribution is bimodal when the histogram has two modes or two peaks, as you see here. This graph shows the distribution of body length between 4 and 9.5. And you can see clearly here that there's a peak at around 5 and another one around 8. So this is a bimodal distribution because it has two peaks or two modes. Using a histogram is not the only way to display quantitative data. You can also use a stem plot. A stem plot looks like a histogram, but there is one difference, a major difference. It shows the actual value of each observation. So instead of having a solid bar for a class, you have all numbers displayed there. How do we draw a stem plot? First, we do a vertical line as the first step. Then imagine you have 50 observations, 50 numbers corresponding to 50 subjects. And your numbers range from 60 to 169. So you will use as stem units on the left of the vertical line all digits except the unit digit. It's except the rightmost digit of all observations. Okay, so you start like that. You put these digits on the left of your line. So if my observations range from 60 to 169, my leaves will range from 6 for 60 to 16 for 169. I put the smallest digit on top and the largest digit at the bottom. And I do not skip any digit. That is very important. Suppose that I have no one in the 90s, no observation between 90 and 99. I will still put number 9 there. Then I complete my observations on the right of the vertical line. Suppose that I have 68 as my smallest observation. I put number 8 on the right of the bar besides the 6, and it makes 68. I have no observation in the 70s, so I leave a blank space besides the number 7. I have one observation, which is 88. I put number 8 on the right of the bar, and so on until my highest observation, which is 168. And I have here my total of 50 observations written. I always put my unit digits in ascending order in the leaves, on the leaf side, on the right side of the bar. My mode here is in the 120s. This is where I have the largest number of observations. I have 120, 129, 122, again 122, and etc. So I put these unit digits in ascending order. I do not put them all mixed up. So I can have a clear view of all my individual observations. And it looks like a histogram. You will see that on the next slide. If I rotate my stem plot 90 degrees counterclockwise, I can see what looks like a histogram, but instead of having solid bars, I have all individual observations. So if you look at this stem plot here, you see that the minimum is 68, the maximum is 168, and it is slightly skewed left.